In this concept, we're going to talk about the Pythagorean theorem. And this is actually a major theorem in geometry. Okay, so the Pythagorean theorem states that if a triangle is a right triangle, so a 90-degree angle, then a squared plus b squared equals c squared. And these are side lengths. Okay, so the square of the hypotenuse is equal to the sum of squares of the other two legs or sides. So hypotenuse squared is first side squared plus second side squared. Let's look at an example. Find the length of the missing side in the triangle below. So hypotenuse is 10, one of the sides is 6, and the other side is a. So we can say c squared is equal to b squared plus a squared, right? And this side b, we can use 6 for b. And then side a is side a. We need to determine. So 10 squared is 100, minus 6 squared is 36. So 100 minus 36 is 64. So a squared is 64. A is equal to 8. Please note, the Pythagorean theorem can only be used in right triangles. Okay, it's only relevant with the right angle and the triangle. The converse of Pythagorean theorem. The converse of the Pythagorean theorem states that in a triangle, if this condition holds, c squared equals a squared plus b squared, then the triangle is a right triangle. Okay? So it's proving the opposite. Pythagorean theorem and its converse can be used to prove whether a triangle is acute, obtuse, or right, as shown below. Let's look at this example. So we have 3 side lengths in a triangle, right? And we need to test them to determine whether the triangle is right, or acute, or obtuse, etc. So we can take the larger side and assume that this may be the hypotenuse, right? Because the hypotenuse is going to be larger than the other two sides. So then we'll say 4 squared is 16, and then we'll test the other two. So 2 squared plus 3 squared is 4 plus 9, which is 13, which is not equal to 16. So this is not a right triangle. Okay. Now let's look at this set of side lengths. Take the larger side, because again the hypotenuse would be the largest anyway, if this were a right triangle. So 5 squared is 25. And then we have 3 squared plus 4 squared is 9 plus 16, which is equal to 25. So this is a right triangle. Okay. Since this condition is met. Now, in case of this condition, right, when the equation does not hold, the triangle may be acute or obtuse, just like we were saying. Now, if the c squared, if the larger side squared is greater than the sum of squares of the other two sides, then the triangle is obtuse. If the c squared, the larger side squared, is less than the sum of squares of the other two sides, then the triangle is acute. Okay. So for example, for 2, 3, and 4, we have the larger side squared is 16, the sum of squares of the other two sides is 13, so this triangle is obtuse, right, for side lengths 2, 3, and 4. For side lengths, for example, 6, 8, and 9, we can take 9 squared, which is 81, but then 6 squared plus 8 squared is 36 plus 64, which is 100. So since the sum of squares of the two sides, two smaller sides, is larger than the square of the large side, then this is an acute triangle. We also have an interesting feature of the Pythagorean theorem having to do with special right triangles. And the special right triangles are the 30, 60, 90 and also the 45, 45, 90. Okay. So for the 30, 60, 90, again we have the right angle, and then we have the 60-degree angle and the 30-degree angle. And the special feature, or the special features of this triangle, are that there are established relationships between the sides. Okay, so the hypotenuse is always 2 times longer than the shorter leg. The shorter leg being the leg opposite to the 30-degree angle, and only when it's 30 degrees. Okay, so if the hypotenuse were 6, you would know that this side has to be 3, half of 6. If this side were 2, if you started with 2, you know that this side has to be 4, etc., etc. Okay. For the longer leg, which is opposite to the 60-degree angle, right, the length is x times square root of 3. So it's the short leg times square root of 3. So the longer leg is square root of 3 times the shorter leg. Okay. Let's look at this example. Find the measure of the missing side length. So here we have a right triangle, 30, 60 degrees. Hypotenuse is 6. And the long leg opposite to the 60-degree angle is 3 square root of 3. So again, based on what we discussed above, right, the hypotenuse will be twice the shorter leg. So if the shorter leg is x and the hypotenuse is 6, then 6 has to be equal to twice x, right? Or we could have said x equals half of 6, right, which is equal to 3. The other special triangle is the 45, 45, 90 degree triangle. And this is essentially an isosceles triangle, right? It's a right isosceles triangle. Because since these two angles are equal, then the opposite sides will be equal for these two angles. The hypotenuse is still the hypotenuse, right? So it's an isosceles triangle, but if you put the hypotenuse, you know, on the base, right? So 90 degrees, hypotenuse, okay? 45, 45, right? Isosceles triangle. So the hypotenuse is, in this case, x squared of 2, and the side lengths are x and x. So if this had sides 4, for example, and 4, you know this will be 4 square root of 2. Okay? Let's look at an example for this. Find the length of one of the legs of the triangle below. So 45, 45, 90. We have the hypotenuse is 2 square root of 2, and we have one of the legs is x. So the hypotenuse is equal to a leg times square root of 2, right? So the leg is equal to the hypotenuse divided by square root of 2, which in this case the hypotenuse is 2 square root of 2 over square root of 2. Square root of 2's cancel out, so the length of each leg is 2 units. Okay. Okay, And here we have our exercises. Please pause the video, work on these, and come back for the solutions. Okay, we need to find the length of the hypotenuse of a right triangle if the lengths of the legs are 3 and 4. So again, c squared is a squared plus b squared. So a and b are the legs, so which is 3 squared plus 4 squared, which is 9 plus 16, which is 25. And then c is equal to the square root of 25, which is equal to 5 units. So that's the length of the hypotenuse. Okay. Next exercise. Determine whether the following side lengths create a right, obtuse, or acute triangle. So again, for each of them, the way to do this is just take the long side, 10 squared, and then compare it to the sum of the shorter sides. So 6 squared plus 8 squared. So 10 squared is 100, and 6 squared is 36, 8 squared is 64, 100, and then 36 plus 64 is 100. So 100 is equal to 100. Therefore, this is a right triangle. Okay. 7, 8, and 16. So again, test the sides. Take the squares. 16 squared, and then 7 squared plus 8 squared. Okay. So 16 squared is 256. 7 squared is 49. 8 squared is 64. So 256, and then 49 plus 64 is 113. So since c squared is greater than a squared plus b squared, right? So this is an obtuse triangle. Okay. And then we have 6, 23, and 25. So we do 25 squared, and then 6 squared plus 23 squared. So 25 squared is 625. 6 squared is 36. 23 squared is 529. So 625, and then 36 plus 529 is 565. So since c squared is greater than the sum of the other two sides, this is also an obtuse triangle. Okay. If the measure of the shorter leg of the right triangle below is 6 units, so the shorter leg obviously is the one opposite the 30-degree angle, right? So this is 6 units. Find all other side lengths of the triangle. So again, if you remember, for this triangle, so this 30, 60, 90, the hypotenuse is 2 times the short leg, right? So 2x, which is 2 times 6, which is 12. And b, in this case, which is this side, is x squared root of 3 which is 6 square root of 3. Okay. Last exercise. If the measure of the hypotenuse of the right triangle below is 5 units, so this is 5 units, right? Find all other side lengths. So the side lengths are x and x. So the hypotenuse C is equal to as we have up here, the hypotenuse is equal to the side x times square root of 2. Okay, but the hypotenuse is equal to 5. So 5 equals x squared of 2. So x, which is the side length, is equal to 5 over square root of 2. Okay? And this is the same for both of these sides. Of course, we can rationalize this if we wanted, multiply by square root of 2, multiply by square root of 2. So you get square root of 2 times square root of 2 is 2, and then 5 square root of 2 on top. Okay? Alright, and this is it for this concept. See you in the next video.